This is going to be interactive, so if I could ask you please to take out a smartphone if you have one and have it at the ready. We're going to use it later. Thank you. But for now, can anyone tell me what that is? Close. They are feathers. That's close enough for me. It's the feathers of an Argus pheasant. Aren't they beautiful? Darwin thought so. He mentions the Argus pheasant a lot in his second most famous book, The Descent of Man. He also mentions the word beauty or beautiful over 300 times in that book. It's really the central question of the book. Why is there beauty in nature? And he doesn't know. Why this should be so, we know not. And if we were to update the writing a little bit to bring us to this century, still the question is wide open. Why is there beauty in nature, and what even is it? So this is something I've been working on with my collaborators, and we've been applying concepts of beauty in philosophy to research on beauty in neuroscience and psychology to come up at least first with a definition, which is that beauty is the pleasure of fluent information processing independent of the function or consummatory reward provided by the stimulus. And to be clear, what we're trying to do here is come up with and develop a testable hypothesis for the evolution of sexual ornaments. So sexual ornaments are those traits that animals use to attract a mate, like the fabulous feathers of birds or the sweet sounds of crickets at night. More simply, what we're asking is, are sexual ornaments beautiful to their intended receiver? And if so, how does that beauty affect their mate choice? So I'm going to unpack this with three different attributes of beauty from philosophy, talk about how those coincide with concepts of beauty in neuroscience and psychology, and along the way we'll talk about how we can apply those to animals and their ornaments. So we'll start with the first attribute, and that is pleasure. Beauty is pleasure. Beauty as pleasure has been with us since really the dawn of Western thought, from Hume to Darwin and to modern empiricists like Brielman and Pelly, for example, who show that the valence of images like these, that is how they make us feel, good or bad, correlates significantly with their perceived beauty. So beauty is pleasure. So then if animals experience beauty, they must be able to experience pleasure. And we think that they do in areas of the brain called hedonic hotspots. So these areas, like the nucleus accumbens, the ventral pallidum, are active when animals experience a food or sex reward. And in humans, these areas are active also when listening to beautiful music or looking at beautiful art. And so these hedonic hotspots are actually also all the way through vertebrates. So these are brain slices of a mammal here. In blue are where the hedonic hotspots would be located. They're located in mammals and all throughout vertebrates, from mammals to fish. So if we wanted to test whether a sexual ornament was beautiful, we could test whether it activates these hedonic hotspots. And that has been shown, at least in white-throated sparrows. These hedonic hotspots, the nucleus accumbens, ventral tegmental area, are active in females when they're listening to a male song, especially if they're jacked up on estradiol, which makes them eager to breed. But notice that does not occur in males who are treated with testosterone. So beauty is pleasure, and we can test that. Next, beauty is an interaction. Oops, yes, good. It's an interaction between the stimulus and the receiver. So we're going to play a game. So our friend Matt here is going to lead us from there. He's going to press on that. Easiest to join with the QR code. That goes faster, so you can press start. There will be a QR code coming up, or you can type kahoot.it into your browser and then enter that code. Don't spend too much time thinking about, a great name for yourself. Just type in some initials. We'll wait till we get a few players. What you're going to see when we start is, first I'm going to show you two blobs, two grayscale circle blobs, and I'm going to ask you which one you like better, the left or the right. All right, are you ready? All right, Matt, let's start. So question number 1, what do you like better, the left or the right? And act fast. You get 10 seconds. Go with your gut. Don't think about it. Correct. Very good job. Good job. Excellent. All right, next. Now next I'm going to make it a little, and next again. I'm going to make this a little harder. You're going to see 4 circles now, and I want you to tell me which one you like best. 1, 2, 3, or 4. Again, don't take too much time. Don't think about it. Gut. Interesting. That is a very interesting distribution. Perhaps not what I expected. Many of you are actually wrong, but that's all right. No, that's fine. It's totally fine. All right, so can we go back to our show map? Thank you very much. Appreciate that, but remember this. All right, so the explanation for our preferences is the efficient coding hypothesis, thanks to Horace Barlow, which is that stimuli that correspond to the statistical features of natural scenes are the easiest to encode. So the environments that we live in have very predictable statistical patterns and features, and brains that evolve there have evolved to decode them efficiently. And they do that by using few specialized neurons that are tuned to the particular patterns of that environment. And they do that over evolutionary time. This is something we know from cognitive neuroscience. What we also know from psychology is that when information is easy to process, it generates a reward or pleasure. Psychologists call this fluency, and fluency is the most widely accepted model of beauty in psychology. And stimuli can be fluent for many reasons. Symmetry, high figure ground contrast, repeated elements can all cause fluency. But it's this effect of natural scene statistics and natural patterns that underlies the field of human empirical aesthetics. So this field hypothesizes that stimuli that correspond to the statistical features of natural scenes are the easiest to encode and therefore the most attractive. So this field focuses mostly on human appreciation of art, and their empirical analyses mostly use fractal statistics or fractal dimensions, of which there are many. And what they've shown is that natural terrestrial scenes have an average characteristic value of these fractal dimensions, and that people are attracted to, they like artwork that matches the fractal statistic of natural scenes. So a famous example is Jackson Pollock's work, which over the course of his career got closer and closer to the fractal statistic of natural scenes. You yourself showed a preference for natural scene statistics. It wasn't as good as I expected, but it was still there. But mostly what you showed was a preference for a Fourier slope, which is a fractal statistic, of minus 2.5. When we showed these blobs to about 2,000 participants online, they showed a peak preference for the Fourier slope at minus 2.39. The Fourier slope of natural scenes is minus 2.4. And it turns out that spiders might also have this preference. So when these were exactly. So when these blogs were shown to spiders, they too had a preference for the Fourier slope of natural scenes over that of another. So that means that the patterns that we like are because they're tuned to our brains. And finally, beauty is disinterested. What does that mean? Umberto Eco said, "We talk of beauty when we enjoy something for what it is, immaterial of whether we possess it or not. The sense of beauty differs from desire." And that aligns very well with our understanding of the reward system, which distinguishes liking from wanting. So wanting is activated mostly by dopamine in many different brain nuclei. Liking is limited to these hedonic hotspots. So that has led many to propose that beauty is liking, but not wanting. So then you might ask, well, how is that supposed to work with a sexual ornament if it's not eliciting wanting, like wanting to mate? Well, we think it works like this. Here's a lizard, female over on the left, that's her brain in the middle, and then there's a potential mate over on the right. She's in breeding condition, so she wants to mate. She sees the ornament, which she likes, and she wants to keep continuing processing it. If she's a social species, she wants to socially bond, and if that male has anything else to offer, she might want that also, like food or shelter. So she approaches. She still wants to mate, she still likes the ornament, she wants to continue processing it. Now she likes the social bond, she might like other things about that male, and all that liking can actually increase the motivation to mate. So it's been shown in rats and humans that endocannabinoids, which are one of the more common pleasure transmitters, actually increase motivation to mate. So she mates. So then just to summarize then, we think that beauty causes liking, which then increases the probability of approach. So to summarize then, beauty is pleasure. It is an interaction, it is disinterested, and now we have a testable hypothesis where we can ask, does the brain act as an agent of selection, shaping the diversity of life that we see? So do other animals have a sense of the beautiful like we do? Is that how the peacock got its tail? I don't know. Some people think that only humans can experience beauty, but I don't think we can accept that without testing it. So thank you very much.